What about going down a group? Do you think elements closer to the nucleus are going to be able to attract an electron more? Or elements as you get farther away from the nucleus going to be able to attract electrons more? Closer to the nucleus, okay? Same reason. You're closer to the nucleus, so your attractive force is stronger. As you move away from the nucleus, your distance is getting greater from that positive charge, so therefore your attractive force for that negative charge is weaker because the distance is greater, okay? So same reasoning basically for these last three trends. Oh, I already told you the answer to my next question. Fluorine. It might help you to remember. Fluorine is the most electronegative element. It is the element that is closest to the nucleus and still has that one spot left for one more electron. Okay, so it wants to attract an electron very bad. So fluorine will be the most electronegative. I want to do the same thing as we just did for our trends. This time, I'm going to abbreviate it EN, electronegativity. So once again, which way are we increasing? To the right or to the left? To the right. How about in the group? Down or up? Increasing. Increasing up. So if we increase up and to the right, our overall trend is a diagonal to the top right, making fluorine the most electronegative element of all on the periodic table. Any questions on electronegativity? All right, we're going to do one more. One more trend. And that's called ionic radii. So we talked about atomic radius. That was when we had a neutral atom. So now we're going to see, well, what happens to the radius when we create an ion? If you remember, an ion was an atom with a positive or negative charge. Well, now we're going to specify what a positive ion is or a negative ion. So positive ions are called cations. In order to create a cation, what do you think? How would we get? Remember, a neutral atom, we have the protons and the electrons are equal. That's what balances out the charge. So if I want to get a positive charge, meaning more protons, what do I have to do with my electrons? Take them away. Okay, so to get a positive charge, A plus, A is just representing any element, okay, A plus, I have to lose electrons. Sometimes that people think of that backwards. They're like, oh, I see a plus sign, so I must add electrons. It's opposite. You have to think, hey, I need more protons because I need a positive charge. Protons are my positive charge particles. In order to get that positive charge, well, then I must take some electrons away because they're my negative. Now I have more protons, so that gives me a positive charge. My negative charged ions are called anions. So in order to create an anion, a negatively charged ion, now I must add more electrons so that I have more electrons, more negatively charged particles, therefore giving me an overall negatively charged atom. So once again, sometimes people think of that backwards. They think, oh, I have an A minus, an atom with a negative charge, so I must have to, negative means take away, minus, take electrons away. But it's not that. This is talking about the charge. Negative charge, adding more negative particles, adding more electrons. All right, so for periodic trend, we're going to have a cation periodic trend because they're going to behave differently, and an anion periodic trend. For group trend, we're going to have just one. They're going to behave the same. So let's think about cations. All right, what did we say have to be, in order to get a cation, what do we have to do? Remove electrons. Does our number of protons change?
No.
Never, right? We can't change our number of protons because then we change the identity of our atom. So protons always remain the same, but I'm taking an electron away. So what do you think happens as I'm moving left to right? If I'm removing electrons, my positive charge is becoming greater, right? Because my effective nuclear charge is still increasing because my protons are staying the same. But I'm removing an electron. So therefore now I have an even greater positive charge. So what do you think is going to happen to the radius as I move this way? And I have a cation, removing electrons. Decrease? Anyone think decrease? It will decrease. It actually behaves the same as our atomic radius. Okay? And that's, I'll put the answer up after we discuss anions. Okay, now let's think about our anion. So remember our anion, we're sticking more electrons in. What do you think is going to happen to my radius if I'm adding more electrons? It's going to get bigger. Why is it going to get bigger? What's going to be happening to my electrons in this outer shell, or all my electrons? I'm forcing more electrons to go in. What do you think the electrons in the shell are going to start doing? If they're going to start spreading out, right? Because now we're sticking more electrons in, so there's more repulsion going on between those electrons, causing that shell and the cloud to get even larger. Okay, so cation radii is going to decrease from left to right, just as the atomic radius did. And this is because our cloud, as we just talked about, is shrinking. Our effective nuclear charge is getting bigger to the right, just as it did before. And now we're removing even more electrons. So that cloud is able to shrink even more because it doesn't have as many electrons now to pull in. Anion radii is the opposite. Now we're shoving more electrons in. So more repulsion happens in that electron cloud, causing the electron cloud to grow larger. So our radius gets bigger with the more electrons added because of the more repulsion going on in that electron cloud. This one to me is probably the one that is confused the most, that I've seen students confuse the most. All right, just think about, well, if I'm removing an electron, that nucleus has more positive charge, holding on to the electrons more, pulling them in tighter, because I have more protons than electrons now to shrink the cloud even more. But when I have an anion and I'm pushing more electrons in, more repulsion. More repulsion means you're trying to spread out more, get farther away from the other electrons. What do you think going down a group? Remember, this one's the same for cation and anion. What do you think going down a group is going to happen to my ionic radius? Increase or decrease? Increase. Okay, because once again, it's just like normal radius for this. I'm still adding energy levels. So with additional energy levels, I'm still growing my radius larger. So that one doesn't change any from atomic radius. Oopsie, sorry. So an increase as you go down. We have one last thing to cover, and that's just creating ions. Any questions on ionic radii?
Can you do the little table then for it?
Well, this one's going to change, so we can't say an overall trend, but we can say ionic radii, cation, and anion, and then going down is the same. So cation, which way are we going to increase if we're talking about cation positively charged? We're going to increase to the right or increase to the left? To the left. So I guess we could do one each individually. We could just say cation. Okay, then we can do another one for anion. What about for anion? Which way are we increasing? To the right or to the left? To the right. All right, so what about our group? Increasing going down or increasing going up? Down for both. So cation radii, what's going to be our largest cation radius? FR, francium. So we're increasing this way. What about anion radius? What's going to be our largest? Remember, leave noble gases out. AT. So increase this way. That help? Yes.
On ours,
Mhm.
we have an extra few.
Oh, y'all do. So that would be TL. Yep. I need to update my periodic table. Yes, so you are right there. Yes, I apologize. If I asked you Ca2 plus, because calcium wants to lose 2 electrons, so it would become a positive 2. We're going to get to that in a second. Or just normal Ca. Which one do you think would have the smaller radius? Ca2 plus or Ca? Ca2 plus, right? Because I'm removing an electrons. When I remove electrons, that positive charge of the nucleus is therefore able to pull in the element tighter, the atom tighter. What if I told you Cl minus, chlorine minus, versus a normal neutral chlorine? What would be larger? The minus, right? Because I'm adding another electron. That's what leads to that repulsion, and therefore a bigger radius. So the Cl neutral would be smaller, Cl minus would be larger. Okay, good. All right, last thing to cover is just doing what I just talked about, creating those ions. This is very simple. Oops. All right, we've already talked about valence electrons, okay? Valence electrons, those are the electrons that are used in order to create a compound. We're going to get much deeper into this next unit when we talk about ionic compounds, okay? But chemical compounds are formed because electrons are either lost, gained, or shared. The only electrons that are able to be lost, gained, or shared are our valence electrons. Our shells below our valence electrons are already filled, so they go untouched. We don't do anything with those electrons. Only the valence electrons. All elements want to create that noble gas configuration. Okay? All elements want to have 8 electrons in their outer shell to become an octet. So that's the goal. If elements such as group 1 and 2 that have very few valence electrons, it's easier for them to lose their electrons than to gain to become 8. The opposite is true of these groups over here closer to the noble gas, 16 and 17. They're so close, it's easier for them to gain 1 or 2 electrons in order to become a noble gas. So what we're going to do now is just determine, well, what charge will these atoms have when they lose or gain electrons? So for example, if we were going to just draw sodium here, if we have our nucleus, and our first energy level, of course, we have 2. Second energy level, we have 8. And then the third energy level, we just have 1. So what do you think sodium, what do you think is going to be easier for sodium to do? Gain 7 more to have a complete outer shell, or lose its 1 on the outer shell? Lose 1. When it loses 1 electron, remember sodium starts with 11 protons and 11 electrons. Well, now it loses 1, so it has 10 electrons. The 11 protons never change. So what's its charge now? If it has 11 positive and only 10 negative, what's its charge? Positive 1. Okay, so that's what I was saying. Yes, we're taking away something, but that gives a positive charge because the nucleus has more protons now than our number of electrons. All right, so that's what we're going to go through the exercise of now. A cation, once again, is a positive ion. Cation is a positive ion. So how once again do we form a cation when we do what with our electrons? Gain or lose? How would we form a positive ion? Lose. So we have to lose 1 or more valence electron in order to create a noble gas configuration. So remember, that is our goal. So it's important to remember here, as we have our periodic table laid out. Group 1 has 1 valence electron. Group 2 has 2 valence electrons. Group 13 has 3. 14 has 4. 15 has 5. 16 has 6. 17 has 7. And of course, noble gases have 8. So we're going to go through some practice here. Making sure we understand this is going to be vital to our ionic bonding chapter that we're going to cover next. Okay, so this is just kind of entry to that. So sodium is in group 1. How many valence electrons does sodium have? 1. All right, so you have to ask yourself, remember everything wants 8. So either it loses 1 to become 0, right? And basically gets rid of that third outer shell altogether, or it has to gain 7 more. So again, which one would sodium rather do? Lose 1. When it loses 1, it becomes Na+. So you write the element symbol, you determine what its charge is. This is just a positive 1. You can write 1 plus if you want. But if the number is 1, you just have to put plus. Okay, barium. How many valence electrons does barium have? 2. So you ask yourself, is it easier for barium to lose 2 or gain 6? Lose 2. So what charge will barium have? Positive 2. We actually write the 2 first, 2 plus. Okay, it's losing 2 electrons. So therefore it would have a 2 plus charge. Our anions are the opposite. Anions are negative ions. So how are we going to form an anion when an atom what for the electron? Gains or loses? Gains. So now suddenly we have more electrons. I'm going to draw fluorine here. So here I have fluorine. Fluorine starts with 9 positive protons and 9 electrons. But what does fluorine want to do you think? Gain 1, right? It's only one way. It's only missing 1 from its outer shell right here. So when it gains 1, how many electrons does fluorine have? 10. Remember, protons don't change. So now it has more electrons, giving it a negative 1 charge. See how that works? Like I said, it might be backwards from what you originally think. You say, hey, I'm adding electrons, I should have a positive. No, if you're adding electrons, you're adding more negative charge. That's why you get the negative charged atom. All right, so let's look at oxygen real quick. How many valence electrons does oxygen have? 6. Everyone agree. It's in group 16, meaning 6 valence electrons. So that means 6 electrons in its outer shell. So you have to ask yourself, does oxygen want to gain 2 or lose all 6? Gain 2. When it gains 2, it will get a 2 negative charge. Any questions on oxygen? All right, bromine. How many valence electrons does bromine have? 7. It's in group 17, 7 valence electrons. So does bromine want to gain 1 to get 8 or lose 7? Gain 1. So when it gains 1, it will get a Br negative charge. Once again, you can put 1 negative if you want, but the 1's not required if it's just a 1. All right, how about argon? How many valence electrons does argon have? 8. What ion will it become? None. Kind of a trick question. None. You can just put none, Na, put argon again, whatever. It will not create an ion because it's happy. It wants to be left alone. Any questions on this? All right, we'll do some practice on this again on Wednesday, just creating the charges. But all you have to think about is how many valence electrons do I currently have? All right, and that way you know if you're going to gain or lose. What do you think group 13 is going to want to do? Lose 3. A lot of students get confused because it's close, based on the periodic table. They're like, oh, it's closer to my noble gas. Just because of placement, but you have to think, hey, it only has 3 valence electrons, so it's going to lose 3. Group 14 has 4 valence electrons, so it behaves differently. I would never ask you to write the ion of a group 14 element. Those are going to be covalently bonded where they share electrons. We'll get there later, but I would not ask you the charge of that. What about group 15? Gain 3. Okay, because it already has 5, it wants 3 more. All right, we already did the other 2. So any questions? All right.